Hello everyone. Today I'm going to go over our scan repair pipeline for a model, in this case a small 3D scanned pine cone. And this process, today we're just going to go over how to repair the model for high resolution 3D printing. Often when we are preparing a model more for WebView or other applications, we'll first remesh the whole thing so it's easier to work with. And then of course there's additional steps to dealing with the texture after the fact. But today, since this is for high resolution 3D printing, we're just going to focus on that. So with that in mind, I'm going to walk through our entire scan repair pipeline, and you can follow along with me so you can see the whole process. So the first thing that I'm going to do is go over some of the settings and other other plugins and things that we use to make this process a little bit easier. I'm sure there's many more that we can use, but these will be a great start to improving your process. So the first thing I want to do is go into edit mode. So you can see right now we have a pretty high resolution mesh. There's a few of these floaters, things that we'll mostly be getting rid of. And then we also need to remove these clamps and the connection points there. So this pine cone was elevated using a helping hands. And so to minimize the connection points. So this means that we were able to scan as much of the object as possible, including the bottom, which is really great. But we do have to segment these off and remove them. And you can see we have quite a few triangles. So one of the first things I'm going to do is go into this menu up here and click Statistics. This is just really handy to keep in mind. I always turn this on. And this will actually show us the number of faces, edges, and total triangles in the model. So especially as you are remeshing, or for example, if you have problems with it's not able to run on your computer, it's always good to double check this first so you can get a sense for the scale. If you're having trouble with 1,000,000 faces, well, that's pretty understandable. But if your model is, if you've remeshed your model down to, again, for WebView, we'll often remesh down to maybe 40,000 faces, which are quads, so twice as many triangles. And that is much more manageable to work with on a variety of systems. But here, this pinecone is a very small model, so we actually are not doing too bad with the 280,000. This runs no problem on my computer, which I have set up for 3D modeling, but you should be able to run this sort of model on your computer as well. So the first thing we do is the statistics, like that. And the next thing I want to show you is this tab here called 3D Print. So you want to, this is an awesome plugin. Let's actually walk through where to set that up if you don't have it already. So you go to, let's see, I think it's in Preferences. And yeah, Preferences, Add-ons. And so here I've downloaded the 3D Print Toolbox. I think you just, you can search it and download this plugin direct from Blender. It's an official plugin. And this thing is awesome. So once you have that enabled, this is really great. So normally I wouldn't run this on quite this large of a mesh. Let's actually see how long this takes. This might buffer a bit. But this check all is what, especially when we're preparing something for 3D printing, this gives you a really great idea of where any errors in the mesh are. Oh, perfect. So now this is actually very good already. Most of the time we'll have some non-manifold edges and bad continuous edges. The bad continuous edges will often come up when you do the remesh and re-import it. So in a later video I'll go over that. But often we'll have non-manifold edges. And non-manifold just means that generally a non-manifold edge is anything that is that's not connected, right? So here manifold means that it's entirely watertight, and consistent. So which is exactly what we need for 3D printing. Often you'll have a few bad faces or other problems that will create non-manifold edges, or when you separate out much of the scan, then you when you separate out the other pieces of the scan, if you have a big scene, you cut it off, then you'll have some non-manifold edges there that need to be repaired. And actually, throughout this process, as we remove these clamps, we're going to create some non-manifold edges. As well with the these intersect faces. Intersect faces are exactly what they sound like. If you've done 3D printing, you know what these are. But this is just when you have two faces that are intersecting each other. So you can see we have a bunch down here, which isn't a problem because we're going to delete all of that. But we may have some in the pinecone as well, which we'll have to remove, and then that'll create non-manifold edges, which we then have to repair. So all this is done manually at this stage in Blender, which might seem like a lot of work. It's because it is, but in order to get the highest resolution scan possible, we need to do all this work manually so that we can ensure the highest quality 3D print, that you won't have any errors or problems with your slicing software later. So unfortunately, the next clip, it looks like I did not hit record. And so what this clip showed was very simple. It was just a step where I select the edge loop between the clamp and the pine cone. And so you do this by first you select an edge, then you use Control Click to highlight to select a continuous, like the shortest path of edges between the currently highlighted one in white and the one you click on. And so I'll do this in several steps to walk all the way around the edge, or sort of the seam between the two pieces. Then you hit delete and delete all vertices. This creates a gap between the clamp and the pine cone. Then I press L on the clamp in order to highlight that whole piece. If it highlights everything, then that means that there's still some connection. So you have to find whichever edge or vertex is connecting the two pieces. But once you delete that and the two pieces are completely separated, then you press L to select the entire clamp piece, delete vertices to remove that, and you'll be left with the hole in the pine cone, as you'll see in the next clip. And of course, whenever you finish up a piece of the model, always make sure to save your work. Next, what we're going to do is we're actually going to fill this in. So now I'm going to go along, and there's different ways to select the edge. For example, if you go to select loops, edge loops. Oh wow, in this case that worked perfectly, or nearly all of it. So then we're going to have to fill this in. In my experience, especially when dealing with the base of the object, often the select edge loop doesn't work very well. It'll select like 5 edges. And so I normally do actually this process I'll show you now. Just like when we're selecting the loop before to make the cut, you make sure this one's highlighted, you shift click to add a single edge, and then you can just go along here, Control click to add the entire edge continuously. Now the place this will fail is, for example, if I'm here, right, so this is the highlighted one, and then I go to here, what it does, it cuts the shortest path, and so then you have to go and deselect those. Right now I'm just doing shift click to deselect those while maintaining the rest of the selection. So you have to be careful of that. Normally this edge select thing, like I said, I have issues with it, so I tend not to use it, but in this case it worked great, so we can do that. And now I'm just going to press the F key to fill this in. This is also in face fill, I believe. And then you go, and then to triangulate this, we Control T. And so this fills in with triangles. Now these are not the same kind of resolution of triangles as the other ones. And so the next step that I'm going to do is to use the knife tool to create slightly more vertices, so that when we go to sculpt this, we can create a smoother kind of form that matches the texture of the rest of the mesh. So to use the knife, we're going to hit K, and this activates the knife tool. And here, there's different ways to use it. I'm just going to show you kind of what I would do in this case, but you'll get a feel for this as you do more of this practice. And so here, I'm just going to kind of make some seemingly arbitrary cuts. Honestly, it doesn't matter too much where you do exactly. The knife tool works like this. These red points are where it creates vertices. And so then if I can do another one here and then here, and you just want to kind of bisect some of these triangles so that it's higher resolution, kind of matching generally the resolution of the areas around it. And you can just keep clicking around to create more of these as you go. You also don't have to worry about, like, these two vertices are very close together. We're going to fix that in a minute, so that'll become much more clear. So just for example, in this small area here, and then you hit enter, and that will create this. These are all highlighted. And now what you want to make sure to do here is, because here's a good example. So if I select the face here, because we made these triangular cuts, this face is now has actually 5 sides here. It's a pentagon. And so what I'm going to do here is just highlight all of this, and then again Control T to make sure that those triangles are all filled in. Now it might look kind of messy. It doesn't look great, and this is where the sculpt mode comes in. So we're going to do a few things with sculpt mode. So with sculpt mode, I'm going to show you a few different tools that I like to use. Here you can see it changes the lighting a little bit. If you don't like this lighting mode, you can go up here. I tend to like matte cap the most. It depends on the circumstances exactly, but this tends to show the sort of the way the light bounces around the best, so you can see the underlying mesh texture. And so I'm going to use a tool. There's different ways to select it. You can go here to the smooth tool, or up here to select. We have smooth and draw. These are the two tools I'm going to use the most, as well as sometimes trim. And then I'm trying to learn some of these other tools. I use the scrape fill sometimes, some of these other ones, but for the purpose of repairing, you're mostly going to want to live with smooth and draw. So the smooth tool does a few interesting things, and you can modify the parameters up here. For this particular application, I'm going to reduce the strength and increase the radius of it. Radius, you can see this has two circles now. The internal circle is like the vertices that are moved strongly, like that are smoothed the most, and then the external circle is the reference points it uses to orient them. And so a shortcut to make this a little faster is you just right click while in the tool menu, and you can adjust these very quickly. So I find that speeds up my workflow a bit. The next thing I'm going to do is the smooth tool does two things. It will actually raise and flatten the vertices to smooth them out. In this case, you can see we have that that patch that was kind of sharp, and it was creating these crease lines. You can see them, and so when I smooth that out, that all goes away. The other really handy thing about the smooth tool is that it will space out the vertices properly. And so you saw with the cuts that we made, we had some vertices very close together and others that were further away, and this will kind of make that more uniform. And so then when we switch back to edge mode, you can see now this looks a lot more like the surrounding edges. So now I'm going to use the knife tool and cut the rest of this area to a useful sort of resolution. And I'm just going to kind of zigzag across this, making sure that I get a pretty uniform set of cuts over the whole thing until it matches the level of the surrounding area. Then I'm going to go and re-triangulate the whole thing, make sure we didn't miss any spots. Then I'm going to smooth this out, and if you pay attention to the way the light reflects, you can actually watch the vertices space out uniformly in real time and sort of fix those congested areas and then the really stretched areas like that. So yeah, there you go. And generally we want to remove any really sharp edges or boundaries indicated by the light refraction, like there. Because it will mostly actually because it renders poorly if you're using this for web viewing, but also for 3D printing you generally want the smoothly connected surfaces, and it's a good indication of the repair area versus the original model, because the original model will be somewhat smoothed. So now we can see that we have a bit of a gap here, and so what we're going to do here is we're going to draw. So I like the draw tool as well. I'm going to around 50% strength, I'm going to reduce the radius there. And we're going to use the draw tool in conjunction with the smoothing tool. So I'm just going to kind of start outlining that. This is just a very artistic process where you kind of look at the references and try and make sure it looks consistent. I like that piece there. And now I'm going to increase the radius and reduce the strength so that I can raise this whole area here to kind of match. And sometimes it's helpful to get a different perspective so you can see how it looks compared to the other pieces, because if you look at it head on, it's hard to kind of judge the elevation. So that's pretty good. I'm going to switch to smooth, and the smooth tends to actually be a reduction a lot of the times. It'll cut things out, because when you have like a raised surface and you smooth, it just draws it into the surface. It seems a little biased that way, so I often just use the smooth to counteract the draw. But in some cases, like here where we've built up the smooth ramp, I'm going to use the trim mode, and that strength is fine. The trim tends to be a bit less strong than the draw, and so I'll trim this away a little bit, create a bit more texture there, because I overdid it with the draw. And then I'm just going to smooth that out a tiny bit. So I'm going to reduce the strength more, increase the radius, and then smooth that out a little. There we go. So I like the look of that pretty well. And you can see that actually the triangles match very well. So comparing to like a reference area, this is actually just a little bit more uniform than the other ones. But that's good, because you want a very uniformly spaced mesh in general, unless there's like specific areas you want to draw additional details in. So I think this looks pretty good. Now I'm just going to go ahead and repeat that process for all the other clamps. enough. Now I'm going to select this entire region and triangulate. And it's okay if you miss a few, like this one so this one missed because I don't have X-ray on actually. So since triangulating, if the full model is triangulated, it doesn't matter necessarily if you select the other side. Although a cool trick you can use here is actually when you're select something like this, you can deselect using the same method. You hold Shift. So actually Shift adds it to it, and then here Control, and then clicking it removes the whole thing. So especially in X-ray mode, this can be really helpful. So now with the selected, I just go Control T to triangulate. I'm going to leave X-ray mode now. If you didn't know, this is the way to toggle X-ray, which just controls whether you only select the surface or if you select the full thing all the way through the entire object. Came out. So next we're going to run this check. Perfect. Okay, so the main things we need to pay attention to are the non-manifold edges. These are any edges on the mesh that are open. Bad continuous edges. This generally means when there's two faces coming together, but there's a duplicate edge, and so they're not actually sharing an edge. This is usually that case, so you need to merge those. And then the intersect faces is of course when two faces are intersecting. These are the main ones we need to pay attention to. The zero faces and zero edges, this tends to happen with scale. There's some sort of cutoff when it thinks that some faces are too small in total area, and so it counts them as zero faces. To fix this, you can go into edit mode, select, and then the tool I use is cleanup and merge by distance. So merge by distance works well. It does exactly what it says it does. This can be helpful when you have zero faces, but normally the zero faces don't show up as a problem. So zero faces, thin faces, this isn't usually an issue for 3D printing in my experience, but if you want to solve that so it's totally clean, then you can use the cleanup tool there. Overhang faces, I've never had a problem with this. This is just referring to like the structures that are going to need supports when you 3D print, and that's not an issue. So I'm just doing a quick visual inspection, and I don't see any additional objects. If you want to be extra careful about like any floaters, any islands, what you do is you select the entire continuous object, and then press, was it Control I think? Nope, not that. You go to select invert. Yeah, Control I. And this will select everything that was not previously selected. So in this case, I don't see anything, but I'm just going to go ahead and delete vertices, and that will delete any loose vertices, edges, or geometries that are not connected to the main geometry. So with that, I think we're all set. Make sure to save your work, and then I'm going to go to Export STL. That works. And then over here, I'm going to open the STL file in Cura just to double check that everything worked. Now that we have the model imported into Cura, what I'm going to do is first scale this up a little bit so we can see it, and then I'm going to slice this. The reason that I always double check the slice of the 3D model is because sometimes when you'll have some weird manifold issues, or occasionally with these 3D scans, it will create like a tunnel through the object, which is technically manifold, so it doesn't get picked up, but is still not the desired geometry. And so when you slice the model and you look at the infill pattern, this often reveals errors that you may not have seen before. This one looks perfect. I think this looks really good. So I will consider this model done. Thank you guys for watching. In the next video, we're going to cover remeshing the model, so that especially for larger models, you can do this remeshing process. Speeds up the repair process, and is also really good for optimizing the geometry for WebView and other applications, as well as repairing the texture of the scan. So this was the first half where you repair the geometry. You got to do this first. And once the geometry is repaired, then we overlay the texture, and there's different methods for cleaning that up as well. So thanks again for watching, and I'll see you in the next one.